Good evening, everybody, and welcome to another vBrownBag webinar. Tonight, we're going to be continuing our Python for DevOps series, talking with Python developers and learning how to level up our skills. Tonight, I am very excited to present Katie Kodes. Yes, that's her real name. That's not true. And she is going to be talking about Python Pandas for Excel. But first, a couple of housekeeping notes. Get in on the conversation. If you at vBrownBag or hashtag vBrownBag, I will be watching the Twitter sphere to answer, field, and address or ask Katie all of your questions. And if you tweet to us either, well, don't tweet to her because she's presenting right now, but if you tweet to me at Mistwire, I will also be presenting, answering questions from there as well. If you are in the live studio audience tonight and you have the Q&A box up, then you can chat with us from there as well. You can say hi and then throw in your questions, and I will hand them to Katie if they are appropriate. All right, so without further ado, Miss Katie, are you there?
Yes, I am, Chris.
No, I'm so happy. Okay, cool.
Me too.
So what I'm going to do is I'm going to cut the power over to you, and you will have all of the abilities. Again, our guest is Katie. She is at Katie Kodes on Twitter. I am at Mistwire on Twitter. So you should follow her. She has some really cool stuff on there, and she also does a lot of stuff in French too. Fun fact. All right, so Katie, I'm going to make you the presenter.
Thank you.
Yeah, you have the power.
Show my screen. Are we there?
I can see it, yes.
Perfect.
Yay.
Thank you, Chris, for welcoming me to vBrownBag tonight. And thank you for everyone with us live for joining in, and for with us not live for joining in when you join in.
For us, for those people in the future.
Right. That's, wow, I'm traveling through time. I am excited to be with you for the next hour and other hours because I'm traveling through time. Tonight's presentation is titled Python Pandas for Excel because I found out about it through Twitter, and Chris had very small graphics and I felt like I had a character limit. So
is that why?
We are not talking about opening spreadsheets in Excel and writing Python code inside of them, just to be clear. We're talking about a library known as a module for Python called Pandas that lets you easily make edits to your spreadsheets that would have been difficult to make in Excel. And I don't like to think of it as Python as a replacement for Excel, more like Python alongside Excel. It's code when clicking just won't do, because I think it's important to keep in mind that you don't really need a chainsaw to slice bread. And there are lots of older code-based solutions to editing table-shaped data that isn't inside of a database. You've got Excel VBA macros, Python CSV module, the Perl programming language, command line shell scripting, Unix tools like awk and set and grep, like everything. But Pandas in particular stole my heart because it's easy, and I'm lazy, and I have a real job to do that some spreadsheet often slows down. So SQL, to me, is the most intuitive set of programming commands for dealing with data in tables the way we humans think of it, in rows and in columns. But we can't use SQL outside of a database. And Python's Pandas module is the second most intuitive set of programming commands that I've seen for editing spreadsheet-shaped data, and you can pretty much run it against any file on any machine that you've set up to understand Python. And setting that up on a machine is also pretty easy, probably a lot easier than setting up a relational database management system anyway. So I am really, really psyched about Python as a workplace tool, especially considering, as you can see from my first slide, that I don't have Python in my job description. And even more fun, Chris let me on to a series called Python for DevOps. And guess what else nobody pays me for?
Make pizzas. No, that's wrong.
Yeah.
That's the wrong answer.
But what I am is I'm a database developer, and specifically I specialize in database integration, extract, transform, load work, or ETL if you want to use jargon that looks good on a resume. What that means is that I write code that moves data from point A to point B. But doing that work isn't always tidy. For example, there are a surprising number of truly legitimate times that I'm asked to edit production data based on a spreadsheet someone emailed me. Or alternatively, if I edit a nightly automation, the next run of that automation could alter tens of thousands of records, and I need an easy way to compare before and after snapshots, see what's different, and analyze whether the things that changed were actually what I meant to change. But I wanted to make sure that I'm being relevant tonight to all of you, so I asked my sysadmin colleague how she uses spreadsheets. And I was really nerdy excited to find out how similar our jobs can be in this way. So she'll convert pipe delimiters into commas and tab delimiters into commas because apparently PowerShell loves to produce tabs or something, like tab delimited data.
Yep, totally.
Okay, and then she'll open the CSV file in Excel and split a last comma first name column into separate columns, and then she'll delete some columns, add some columns, rename some columns, reorder some columns, drop any rows where the user ID doesn't appear in some other spreadsheet she's got, and then she'll upload the new file into the latest cloud system that a business user just got back from a conference and insisted they need. Oh my God, that sounds familiar. So I love Pandas for this kind of work because its syntax is pretty. I can ask for forgiveness instead of permission when installing it on a work machine. It's pretty, like compared to things I've used before. And finally, because it's Python. There is a module for everything else that I might need to do in conjunction with editing the spreadsheet data. So once I've made that jump to I need to code this, I don't have to write 2 programs in 2 languages for a small script. So how do I decide when it's time to make that jump and edit a spreadsheet with Pandas? Because there definitely is a cost to pulling out the chainsaw if you need to slice bread, not trees. And I mean, I really, really love that graphic. I could not believe when I Googled it that I found it. Well, firstly, it's not an either-or proposition. I toggle back and forth between Excel and Python within the same project all the time, using each tool for like 5 minutes where it's easier. But I'd say that my motivations to edit a spreadsheet with code break down into 3 categories. Huge files, a need for automation, integration, complex conditions, etc., like all those reasons that you'd normally program any human task with a computer. And then finally, combining or comparing multiple spreadsheets. So let's do a quick compare and contrast for each of those categories. First, we'll have a look at removing rows of a 100,000 line CSV file in Excel. And tell me if you don't see my mouse moving, because this is a video of a screen thing. Is it going?
Yep, it's going.
Perfect. So I am selecting 4 countries that are conveniently high in the list because they're early in the alphabet, and saying that those are the countries that we don't need from this sales data, and deleting those rows. And it's going to take like 6 seconds. We're on about 100,000. We're on a 100,000 row spreadsheet. I tried doing this with 1 million, but the video took 30 seconds, and that was a waste of your time. And then I get even a nice little screen freeze, and it's done. So that particular operation probably still worth doing in Excel because it only took the 6 seconds and it was easy. But if it had been bigger, I probably would have wanted to do it. So in this video, I've extracted the important part of the code and put it in the right. It's the same code that's at left.
Nice.
And you're going to see me hit the run button, and it's going to think about it. That 3 seconds that it's thinking about it is actually loading in the data. It's opening the files. You can see that when I did it in code, it actually took a 20th of a second to do the 100,000 row spreadsheet we saw earlier, and it took a 1/5 of a second to do 1 million rows. That took me 30 seconds to a minute on my nice work computer in Excel.
Very cool. That's awesome.
Yeah, so you can see it's not that bad of code. It's 11 lines of code with a couple of line breaks. So, and then half of it's half of it's just tracking the time that it took. So we just set up a Python list of countries that we don't want. We have a nice little command called read_CSV, and we just pass it a file path. And then the magic is in line 10. And what we do is, let's see, working our way kind of from the middle out, like you would in an Excel formula. That df1 bracket country is grabbing the countries column, And then going to the right, we are transforming that into trues and falses based on whether they're in those countries.
Mm-hmm.
And then on the left, the tilde is doing a not, so this is more of a not in. And then when we put that whole thing inside of df1 bracket, it's going to keep the rows that mean where the result is true.
Mm-hmm.
So the rows that are not in those. And then we're just going to do an x equals x plus 1 kind of overwrite this statement and
For DF1,
save it out.
for the list, right?
Yeah. So that's how that's working. We'll go a little bit more into stuff like that. But let's now talk about the kind of
Actually,
tedious.
I have a quick question from the audience. Is that IPython? Is that local, or are you running that across the web?
That is local. It is, I have Anaconda set up, and this is the Spider IDE.
Oh, okay, all right. I saw IPython, so I thought that was the web loaded version of that. That's really nice. That's super slick.
Yeah, but there is something called Replit, repl.it, that you can basically do this in. You can upload your CSV files into it and just start coding without having to install Python. And we'll talk about that too, because I think that's just the best thing ever for people who've never done this before, and you want to try it before you buy it.
Yep.
So, yeah. So let's take a look at doing some repetitive stuff in Excel. In this case, am going to add a notes column because I have some exploration and analysis of this sales data to do. So first thing is I'm going to take regions that begin with capital M and orders with a code of M, and I am going to make the insightful comment that they both start with M. And this is why nobody actually lets me analyze sales data for real. So then I am going to grab Canada and Greenland and mention that I think it's cold there. Sorry to pick on Canada. I know that Vancouver is quite warm.
It's like literally an hour away from me. What are you doing?
And finally, we're going to do something that actually a real salesperson might do. We are going to look for orders with more than $5 million of revenue and flag those as we scroll down, you might have noticed it flash by real quick that one of them was already in Canada or Greenland. We just overwrote that because we're just kind of blasting through here. And so that was our edit, and that's what we just did. So let's look at how we do it in Pandas, but just to talk a little bit about the kind of code we're dealing with, I just want to show you the Canada-Greenland part of what we're going to see played out in code. So to code the Canada-Greenland note-taking, I think it takes about maybe 4 variable assignment statements. We could definitely do it as a one-liner like code golf, but I would hate myself if I had to read that in a year, so let's say 4. And I love this code snippet because it shows off the devil's bargain that the inventors of Pandas had to make, trading short and sweet, pleasant readability against a hellacious nightmare of eternally wondering what a given square bracket is actually supposed to do, especially if you're new. So when you're reverse engineering code that you find on Stack Overflow, you're going to want to break the example apart the way I've done here and play with putting each subcomponent of the code into a print statement or a print type statement to figure out what's really going on. And to that end, I want to show you a little bit about all the different things that square brackets can mean. In this example, the square brackets in the first line of code, they're not Pandas at all. They're just an ordinary native Python list. The second line of code, a square bracket with a single column name is used adjacent to df. And df, it's not shown on the screen, but it's that read CSV thing. It's where I stored it. So we're going to extract a copy of the data found in the country column of our table, or as it's called as a Python data type, a Pandas data frame that I saved into this variable called df. And in the third line of code, miraculously, we don't have square brackets. What we're doing is making a list or a Pandas series that is a copy of the data in our country column, which was also a series. Only instead of it saying Libya, Canada, Libya, Japan, etc., it says false, true, false, false, etc. depending on whether the country has been deemed cold or not.
Based upon the list, Canada or Greenland.
Yes.
Gotcha.
And then finally, we have a double whammy in the last line of code, and it's kind of a doozy. We have df bracket notes, which is a lot like df bracket country in that it selects a column from the original table. However, because it's on the left-hand side of this assignment operator equals symbol, it's primed and ready to actually change the values stored inside this table df as long as those values appear in the notes column. But wait, there's more. So remember that cold rows is a list of like false, true, false, false, etc.
Right.
If we put a list like that inside square brackets to the right of df bracket notes, then all the rows of the notes column where the corresponding value by position in a list, so like the first one to the first one, the second one to the second one, where those values are false, those rows are going to be ignored. And
Gotcha.
so Burr cold is only going to get written to the cells of the notes column that are in a table row where the country is Canada or Greenland.
To the true cells.
Yeah.
Nice.
So, yeah, it's a lot of different meanings to the brackets, and that can be really, really hard if you're just like, what is going on here? So just knowing, I once had it explained to me that Unix command line scripts weren't full of cryptic one-character toggle settings because people thought they were too smart to have to write real stuff. It's because the whole thing was invented before we had graphical user interfaces and could just click checkboxes.
Mm-hmm.
And so people who spent all their day at a command line, they didn't want to get repetitive stress injury. They knew what they were doing. They wanted to be fast to type when they had to do it over and over again. This has got a little bit of the same phenomenon going on. There's a memorization curve to get over when you're actually trying to write it, but it'll be faster once you know it. And it also probably takes away a lot of punctuation that could otherwise make it harder to read at a glance. So let's actually watch it run. I've got my 1,000 sales records, and I'm going to pull up code that is basically like what I showed you. I'm just doing all of the edits now. And I just ran it, and there is the 1,000 labeled, and it's got all my things.
And how long did that take? That was like just a couple, like less than a tenth of a second.
Yeah, less time than it took me to realize that the program had run by looking in the right-hand side. So, yeah, you can see I've got in lines 5 through 9, I've got kind of that first thing where I'm grabbing the rows, and then I decided to do all my edits in one big chunk. So basically 3 times what I showed you for the Canada-Greenland example. And so, ta-da, bracket magic, which sometimes feels like it would have been maybe a more appropriate name for the Pandas module, but that's why they don't let me name things. So last but not least, combining spreadsheets. This one's going to be a little bit of, it kind of makes me feel like instead of showing you a Python video, I am just teaching you an Excel training. So there is some data I've got with people and where they work. It's from one of my company's contact databases. And then we've got another database we picked up from a cafeteria we run. And it's got people and their favorite foods. And in green, I've highlighted the people who I already happen to know are going to be in both spreadsheets by name and email address. That little red one is me highlighting that Albert Howard. He's in there both times by name, but we decided name and email had to be the match key, and he's got different email addresses in 2 spreadsheets. So he's actually not going to count.
Darn it, Albert.
Yeah. And all of these are some pretty cool people, so you can go look them up on Wikipedia.
I'm familiar with most of the names.
Nice. we have to talk about that then, because a lot of people might not be. So what I am doing first to prep my data in Excel is just concatenating first name, last name, and email, because you can't multi-column join in Excel the way you could in SQL. So I'm just making a new thing that has all that data as a column. Mm-hmm. And what we want to do is tack on favorite food and maybe the ID from the other spreadsheet to anyone who happens to be in the other spreadsheet. We'll just leave it blank. This would be known as a left outer join if you were in the world of databases. So we have this crazy formula that's a lot like a VLOOKUP, but you don't have to pre-sort your data, so I actually like index match better than VLOOKUP. And I was just showing you that this first set of data we want is in column A of the second spreadsheet, and that's why it says A through A, and the second piece of data, the actual favorite foods, they are in column E of the second spreadsheet. So that's why they vary ever so slightly differently.
Gotcha.
So we're going to grab that first formula and paste it into our first cell. And we're going to copy it down. And I used my little $ things to try to make it friendly for copying down, but not sideways, but keep it preserved sideways and stuff. And so then we're going to do that. And there's our data. So that's what we were going for.
Mm-hmm.
That's a 2.5-minute video of Excel in a Python training. So that's awesome. And with this problem, I would say we're definitely looking at cutting logs, not bread. Mm-hmm. Every single cell of every single column in Excel has to have this terrible formula. And if somebody were to insert a new column into the favorite foods sheet between columns A and B, the whole thing breaks. Pandas, on the other hand, does what we tell angry 3-year-olds to do. Use your words. Like everything can be specified by name, not just by position.
I'm sorry.
It's better behaved.
Gotcha.
Yeah, Excel's having a tantrum. And as a bonus, we get all the columns from our second spreadsheet in one command, not just like one cell at a time. And so it acts a lot more like a SQL join than Excel could ever dream of. So we have our two files, .xlsx, and we are going to go back over to our Python, and we've got, we're importing that, and we're specifying outpath left. Two different output things. Sorry, God, I just ran the thing. I didn't even show you the code. I'll go back and freeze it, because that's how fast it was. So we now have an output file that looks a lot like what we made in Excel. But what's really interesting is if you wanted to do what's known as a full outer join, where you have everybody from both spreadsheets, but you do put them together if they were in both spreadsheets. That's not at all easy to do in Excel. That's when you're like importing your Excel spreadsheet into Microsoft Access and doing crazy stuff.
Right.
Which is a nightmare if you then have to replace it with Excel spreadsheet of a slightly different name and set the whole thing up again, whereas it's really easy to just backspace something and like change a date in the file name in Python. So let me rewind this video to the actual code. So we're setting up that we're bringing in the spreadsheet on line 2. Line 3, we're saying where I want to put it on my hard drive. Line 7 and 8, we're actually giving it the names of the spreadsheets and saying, okay, we're going to have DF food is the first spreadsheet, DF email is the second spreadsheet. Then, because if there is a way when we do the join to just say I want the left-hand side to use these 3 columns and the right-hand side to use these 3 columns, but then it would like include them all, and it just kind of looks stupid to me to have the last name repeated twice for everybody. And so to make sure that they all appear in one stack in one column, it just is a lot easier if you just rename the, how did I do that? Okay, I had employment first, right. Sorry, I have them backwards in line 7 and 8. Like, I'm like, what am I doing? So I took what I'm thinking of as my second spreadsheet, the foods one, and just renaming certain columns to be the exact same column titles as I found them in the employment spreadsheet. Gotcha. Line 13, yeah, line 13 is I'm doing my join, and I'm writing it to a brand new variable just so I can keep my mind straight on what's what. And so what I do is I see df underscore employer, which was one of my tables that now by the way, you are not actually editing a live spreadsheet until you write it out with 2CSV or 2Excel or anything like that. You're editing an in-memory copy, an in-memory abstraction of what you read in off your hard drive. So don't be afraid to get rid of things and make mistakes unless you actually have something in your code that says 2CSV and 2Excel and it's the same file path that you read in from. So do a save as. It's the equivalent, give yourself a different file name for the output than you had as the input, and you can make all the mistakes you want. Right. So what we're doing is we're setting up this new in-memory table that is the merge of DF employer to DF food, and we're saying that we want it to be like a quote left join, which means only stuff from DF employer stays. You don't get to just add people from DF food unless they're already in DF employer. And then the on is just how we want to decide that somebody is in both spreadsheets. And then line 14, we're doing the same thing, but we're saying that we want a full outer join, and so we want people from both spreadsheets, but please do put them together if they match on those columns. And then finally, we just write them to disk. So that's our cute little script that is a lot faster than setting up Excel. And on the final slide, I'm going to have a link to a place where you can get this data and a whole bunch of other resources. And so that's how Pandas has changed my life and boosted my productivity. And I want it to boost yours. But if I'm honest, I'm not going to teach you like all the bracket magic in 20 minutes. So I'd like to spend a few minutes talking about how best, in my opinion, to learn the bracket magic. Because Pandas is extremely popular and extremely well documented. But there are a lot of gotchas that make it harder to get started than it actually really needs to be. So to you, a spreadsheet probably looks like this. One row of column headers, lots of data rows. And if you work with CSV files a lot, you probably recognize this on site as the same data. It has the same shape. One row of column headers, lots of data rows.
Right.
If you import a spreadsheet into Pandas as a data frame and you display it on standard output with a print command, same thing. One row of column headers, lots of data rows. It's probably the closest thing to Excel you'll ever see on a terminal screen.
It actually prints it out like that.
Yeah, there are some line wrapping issues, and there are settings that can make it better or worse. Yeah, with really wide spreadsheets, there's no scroll bar necessarily.
I'm used to like a mass of letters, so that's really cool. I mean, even if it looks somewhat like that, that's still cool.
Yeah, I think the biggest issue is once you start getting into wide data, you're gonna have to like just print a few columns at a time.
Yeah.
Or you're going to want to just write it out to disk and open it in Excel and scroll left and right and look at it. Again, I flip back and forth a lot because not everything is fun to do at a terminal console. So that's all really nice. And then you're like, great, this looks easy. I'm going to search the internet. Pandas beginners. Intro to Pandas. Pandas tutorial. Pandas documentation. And you'll get tons of well-written results if only you could get past their first paragraph. Because when you read a Pandas tutorial, the example output will usually look like a table, but the example input won't. And so it'll often be written more like you're seeing on the screen now. There's no header row, and there's like one row per record, but the column names are repeated in every record on a cell-by-cell basis. And that gets really ugly when it starts to line wrap. And if you've ever retrieved data from an API over the web, this might look really normal to you. It's a very common way to represent a table as text without actually depending on line breaks as punctuation, which can be super important going from computer to computer where line break standards are a little different. And this structure is really common when representing a table as text formatted to the JSON or JSON punctuation standard, which is used a lot over the web.
Yep.
And making explicit the fact that every cell of every row of a table has a corresponding column header, whether you see it or not, it's more like that, and therefore can be processed independently of its sister rows, actually can help your mind keep track of what's going on with advanced transformations that you can do with Pandas. But none of that really helps it feel less foreign the first time you see it. And then there are the tutorials that are really going to break your brain, because what they show you as input data, instead of presenting a list of overly eagerly labeled rows, they give you a collection of individual column contents. Again, not wrong. Really, really useful to statisticians, because tables are a uniquely special snowflake kind of two-dimensional data, where up, down, and left, right have special meanings. And the moment a data scientist starts pivoting or graphing or grouping or aggregating that data, it might get transformed into 6 dimensions, then down to 4, then up to 7, and down to 1. And it's a lot easier for statisticians to think of 7-dimensional data as 7 different types of list from the get-go than it is for them to try to think of what's going on with a table. So my recommendation is that if you're reading a Pandas tutorial and you feel lost as soon as you see the example input, don't despair. Just whip out a paper and pencil and start playing with drawing that data in as many different shapes as you can until one clicks for you. And then go on reading, because I promise the rest of the tutorial is like, there's lots of really good stuff. And this same paper and pencil exercise can be really helpful in discovering a section of Stack Overflow that is friendly. I guarantee you're not the first person to ask a basic syntax question on Pandas. My biologist neighbor, she uses Pandas, but she otherwise can't program. But we got talking at a block party, and she was like, I love Python. People following the Pandas tag are used to newbies because it is such a sort of next step from Excel kind of package. So my recommendation to get good help and to ask good questions, which Julia Evans has an amazing blog post about called Asking Good Questions, is to make sure that you doodle your data the way it looks as input and the way you wish it would look as output, and then like put that in Notepad++ and get it 4 spaces worth of indentation at least, because then when you paste it into your question, it'll show up as a code snippet, and then it will be all of the letters will line up under each other. It's fixed with text at that point, and so you can really sort of draw like a pseudo table and let people see what you're trying to do visually. Like don't make them think. And that's actually, you don't have to know a lot of programming. You just have to take some time making sure things sort of look like what you want. And if you're still embarrassed, ask what the most Pythonic way to solve a Python problem is, especially after you've shared some code from your first attempt. Because as weird as it is, there are some people in the world who aren't interested in answering questions about how to do something, but they totally have an opinion about how to do something better. So take what you can get. Pythonic is your abracadabra of bringing those people out of the woodwork to answer your questions.
And you can meet them all at PyCon every year.
Yes.
They're amazing.
Yes. Pythonic just means the way people who program Python every day love to do it. Mm-hmm. It's a style thing. So you can guess your way through Pandas without learning it for real, the same way you can with Excel's many functions. I mean, I don't bother to learn Excel functions. I Google my problem when I need to. And that said, we are still programming. And so the guesswork is going to go faster with a few programming 101 concepts under your belt. So Chris, or people in the chat room, feel free to interrupt me if you think I'm going too basic in the next few minutes, but I want to make sure that everybody comes along, but I don't want to bore anybody. So first thing I think is you have to understand the difference between an expression and a statement, because they're both words that mean small fragment of code. An expression is code that becomes a value when you run it. It's Katie, or it's 3, or it's 6 plus 5, which becomes the number 11 when you run it. Mm-hmm. Everything in Excel that you've ever typed into a single cell is an expression. Expressions, when run, they are something. But in code land, they don't just show up on your screen the way they do in an Excel cell, which brings us to statements. So a statement is a code snippet that does something noticeable to your computer when you run it. And it might have expressions inside of it, but it's more than that. It is a complete sentence where an expression is more like a noun phrase. And so if it contains the print function, it'll display text on your screen. If it contains an assignment operator like the equals symbol, it'll save a value produced by an expression into a variable. Or it might write a file to your hard drive. So statements, when they run, aren't anything, but they do something. And that's all you need to know, but it is important because there are tons of Pandas functions that by default make your code behave like an expression. They return an altered copy of your input data that you need to do something with, like our merge thing that we did, where I saved it out into another list because otherwise it would have thrown it away after it computed it. But a lot of those functions offer an optional parameter called inPlace equals true that makes your code behave like a statement and actually alter your input data. So you don't have to have that equals, and it'll just like edit the thing that came before the dot of the function. So that's important to know. It's kind of like the old saying that you only need 2 things in life. duct tape and WD-40 lubricant. Something moves and it shouldn't, apply duct tape. If something doesn't move and it should, apply WD-40. If nothing is happening and you wish it would, you might need to add some sort of statement, whether that's like an assignment equals or whether that is the in place equals true. And if something is happening and you wish it wouldn't, maybe you need to get rid of a statement.
So this is a family-friendly podcast. I'm glad you didn't say the last part of that statement. So kudos to you, Ms. Katie.
Okay, I don't know where we're going with that, but okay.
No. Oh, you don't know the last part of that. Oh, I'll tell you afterwards.
Duct tape? Wait, there's more to the duct tape thing? Oh, well, I found it on somebody's funeral brochure, so it probably was family friendly there too. Geez, I'm gonna have to look this up now.
I will tell you after we stop recording.
I'm intrigued. So yeah, and the thing is, in Pandas, statements can be a little bit tricky to find because they can be hidden as a parameter to a function. So just keep that in mind and know what the difference is. Functions and operators, they're simple. They're the glue that combine expressions into bigger expressions or into statements. Operators are the things like plus and 5 plus 6 or the square brackets that we see everywhere in Pandas. Functions are the commands made up of a word followed by parentheses, just like they are in Excel. Sometimes they stand alone like in Excel. Other times they're connected to the right-hand side of an expression with a period, no spaces. And understand that parameters are the things that go between the parentheses as input, but that if it's the period kind, any expression to the left of the connecting period is also input, and then that the output is called a return value. Knowing those things are going to help you read official documentation. And last but not least, it helps to think of data the way a computer scientist would think of it. So if you edit an Excel cell and type equals Katie divided by 3, you're not going to get a tidy answer. You're going to get like that hash value exclamation point thing. And the reason is that divided by is an operator that expects 2 numbers, and Katie has a type, it's text, and 3 has a type, it's a number. So certain things just can't be done to certain types of data. But because you don't get this instant visual feedback, you kind of got to keep track of data type yourself. Luckily, just like Excel, Python has a type function that when you wrap its parentheses around an expression, it'll tell you the data type. So use it, Google the results, and see what you can and can't do. But data doesn't just have a type. Some types of data, like lists and tables, they can have more data inside of them. And we describe that by talking about how many dimensions the data has. So 0-dimensional data, like 3 or Katie, that's a single piece of data. And 1-dimensional data, like in geometry, that looks like a line. And so it's a list of 0-dimensional data. And then 2-dimensional data, like in geometry, it looks spread out flat. So it's like a list of lists or a table, and you can go so on and so forth, but you can kind of just start breaking it down into like this idea of, list of lists. They're lower dimensions inside of the bigger dimensions. And dimensionality is also going to influence what you can and can't do. So even though division deals with numbers, strictly speaking, I can't divide a list of numbers by 4 because it doesn't take a list, it takes 2 numbers. And you might be thinking like, well, could you divide each of them by 4? And yes, I could, but it's not the same thing technically, and just knowing that is important. So what that is an action that you can't do to a plain number, but that you can do to 1-dimensional data, 2-dimensional data, etc., called iteration, also known as looping, or just doing something to everything. And then aggregation would be involved if we divided the average of the list by 4. And selection would be involved if we divided the last number in the list by 4. All these list-specific operations, they help us ensure that the division itself has the dimensionality of input that it's actually expecting. And just like 0-dimensional single-point data comes in many types, like text, numbers, true, false, 1-dimensional data also comes in lots of types. So you've got lists, you've got sets, you've got dictionaries, also known as maps or hash maps, which can feel more than 1-dimensional because they're labels in addition to the raw data inside of them, but it usually helps to think of them as still shaped like a line. And then you have specialized objects like Pandas series, objects and classes. And if you know nothing about what an object or a class is, you don't have to look into full-on object-oriented programming best practices, but just enough to understand the whole, like, what's the cookie cutter thing. That'll help you out. And these all behave differently from each other, and there are different things you can and can't do with different data types within a dimension. So last but not least, because looping over data at higher dimensionalities is so fundamental to getting anything useful done, it helps to just recognize exotic forms of loop when you see them in the wild. And Python and Pandas are full of them, so that's why I wanted to cover that. Python comes with a punctuation trick called comprehension that makes it very concise to write simple loops. And you don't have to know how to write them, but you'll see them enough in the wild that they're worth recognizing, because otherwise it could be a little hard to read along. At the very least, you're going to want to say, okay, what's that thing that's inside of opening and closing brackets, and punch it in on its own to a print or a print type and just see what it does. And then, like Excel, Python and Pandas are full of functions that implicitly loop over, aggregate, or subselect on a collection of data. For example, this sorted, you can put something inside the parentheses that's kind of list-like, or this dot is in that can come out of a sum series. It takes that series thing as a list and checks one by one whether each member of it is in something else. It's not checking like at the same, it's not like taking the whole thing as a clump. It's going item by item. And so that's a loop, but it doesn't say loop or for anywhere in it. So just don't be surprised and think, oh, okay, it's just doing my looping for me when you see it. So when you find Pandas code online, tinker with it. Take it apart and figure out what each piece does. Chris, have you ever needed to do something in Excel and you found some MVP's blog and there's this neat solution that is like 12 parentheses deep and all meant to fit in one cell?
Oh, yes, yeah, and it scrambles your brain.
And like what you do to unscramble it, because you need to edit it, is like you kind of start in the middle,
Yep.
and you take that and put it in a cell and see what it does. And then you're like, okay, let's take the middle plus one parentheses. And you just work your way from inside out to see what it does, right?
Mm-hmm. Yep, totally.
And so I'd say do the same thing here. And my top 5 recommendations for seeing what exactly an expression does is to run it surrounded by print, run it surrounded by print type, and Google any unfamiliar results. Don't be like me when I was a kid and I would ask my mom what a word meant, and she'd, when I was reading a book, and she'd say, go look it up in the dictionary, we have one. I'd be like, and keep reading. If it seems like it might have a size, if it seems like it might be a list or a table or something, run it surrounded by print len, which is short for length, and see what comes out of that. And then finally, and then if it's a Pandas data frame or a series, you can add .head before you put the print thing around it to just get like the first 5 lines, or you can put a number inside the parentheses of head to say how many first lines you want. There's also one called tail. That's pretty handy, just because, so you don't have too much information on your screen if you already kind of know that it'll all be pretty consistent. And finally, flip, like I've gotten the last 2 bullets here, like play around with flipping knots, like trues and falses. Like if you've got one of those little tildes that means not, or you've got the word not, take it away and see what happens. Because for example, it's a lot easier to tell that I kept every row in those 4 countries than to tell that I got rid of them by looking at the first 5 lines. So I can tell if I'm on the right track sometimes just by flipping things. So that is how I steal code from the internet and use it at work. And you should steal code from the internet.
Everybody should.
Yes, like Excel, like any scripting language, Pandas is full of party tricks. And Kevin Markham is posting 2 #Pandas tricks a day on Twitter right now. And they're really short and sweet, and they come with little pictures of how your data is transforming. And they're often slicing bread-sized examples. But I want you to whip out your Pandas chainsaw and try them, because it's going to improve your finesse with the chainsaw. And some of them might actually even be useful in production. For example, I used Pandas to write these slides. So remember the blog post where I was talking about ugly input data?
Yep.
Yeah, so I typed the table the first time in Excel, saved it as a CSV file, and then I did my read_CSV to get it into Pandas. And then it turns out that there are some 2_dict commands that I found just like, this ought to be possible. I know Pandas has a whole lot of import and export things, and I just looked up data frame. I was like, what can I do here? and I was able to put it inside a print statement and get it on my screen so I could copy it and paste it in Excel just by finding the right parameters and trying them. Actually, the way I found the right parameters was I tried all the ones in the documentation until I was like, oh, that's what it should look like. So moral of the story is if you can visualize a data transformation and there's a table or a spreadsheet involved in what you're visualizing, Pandas can probably help because it's been around long enough that people have complained about everything. And best of all, you don't actually have to install anything on your computer to start practicing Pandas today. So step one, open a web browser. Step 2, visit repl.it/languages/Python3. It's even mobile friendly. So really no excuses. I've
really?
actually done this. Yes, they did a great job.
Wow.
Step 3, write some code. Step 4, click the big green run button and watch your code run. It comes with Pandas as a module, so you just have to type like import Pandas, and you can upload files into a project, or you can point the read CSV command at a URL, so you can have the file already out there on the web. Easy peasy. Just promise me not to upload your corporate data into Repl.
What? Why not? Why would you not do that?
That's when it's time, Chris, you need to go to the hardware store and buy your own chainsaw and install Python on your computer if you're doing that.
Oh no.
Yeah, so I have a blog post about how to get started on Windows. I don't own a Mac, or I totally would have screenshotted it then. One of these days I'm going to borrow a friend's computer and try it on all the operating systems. So Anaconda is a executable installation thing that'll put everything you could need and more for all the common packages, especially for analyzing data, which Pandas is definitely one of, on your computer, and it'll install that Spider IDE, and you'll basically get a big green run button of your own on your computer.
There actually is a chocolatey install package for Anaconda 3 that you can use. Do you use chocolatey? Are you familiar with that?
I don't. What's that?
I will tell you all about that when we stop recording. Chocolatey is basically a package manager for Windows. I'll tell you about it afterwards. It's amazing. You're gonna love it.
Oh, nice. So you don't have to keep doing like a command line conda install or pip install kind of thing?
It's basically that for Windows. You can install everything, like all the things. Python, Anaconda, Node.js. I'll tell you about it later. I'm sorry, I didn't mean to interrupt.
And again, if you want to try the chainsaw before you buy it, just go to Repl. They've got your back. Just literally, make up your own sample data and start coding.
Awesome.
Yeah, so that's it for the lecture part of the webinar, and I am not the best person on the internet to learn Pandas from. I'm just a saleswoman.
I highly disagree with that. That was fantastic. You even have your own QR code at the end of this. I mean, who does that?
I do.
That's amazing.
Well, I don't know. Like, what if somebody I don't know. Never know. But I do have a link. katiecodes.com. Oh wait, the link is wrong. You guys, you're not going to get there. Hang on. I don't have it ready to edit. It's not vBrownBag 19 anymore. You know what? I'm going to see if I can set that up as well. It's VBB 19. I shortened it.
Oh, okay. Well, that's what you have on your link that I spammed out too, though. VBB is the right one.
I wonder if the QR code's wrong too.
Oh no.
Okay, guys. katiecodes.com, all lowercase, codes with a K, /VBB19. But I'll see what I can do about making sure they both work.
I will not screen cap that just in case it sends them off to someplace terrible. if the QR code is
no, wrong. It would send them to VB. No, I won't. It'll go to a 404 if anything. It'll be fine.
Okay. Well, then I'll take a picture of it. So
yeah, that is where I gush exuberantly about my favorite teachers and give you lots of resources.
Awesome.
There's one resource there's one resource I did not include, which is facts about Pandas. You did promise I was going to have some bear facts, but I do not have bear facts, Chris. I don't know if you have any bear facts you'd like to share.
I don't. I was when every time I think of Pandas, I just immediately the first thing that pops into my head is the module, but then the second thing that pops into my head is the actual bears because they're so adorable.
Yeah. So we are ready for Q&A. If we run out of Q&A, we'll see if we want to do any sort of live coding, if I can even get it to work. But let's start by seeing what people have to ask.
So the questions that I had been asking as I was going were the questions that were being fielded. As of right now, I don't know. Graham is asking, am I going to do a talk on chocolatey? No, I'm not.
Nice.
No, so normally at the end, hold on, let me, okay, Graham's putting in some links. So when I don't have any questions at the end like this, that usually means one of two things. One, it was either crazy over everybody's head and they're all glazed, or two, and this is the case for this one, it was so well documented and so in depth and so well explained that there's literally no questions left to have. This was killer. This was amazing.
Sweet.
This was I super loved every single last second of this. I'm gonna have to go back and rewatch it on slow because I was tweeting out the whole time too, and Fozzie was sitting here in my lap demanding pets. So he was as infatuated with this as I was. I'll have to take a picture of him and send him to you because he's
Fantastic. Well, do you want to spend our 10 minutes? I presume you're cropping the video. Do you want to spend our 10 minutes, like you said you wanted to get some practice with Excel? Do you want to do a little bit hands-on? And
absolutely not. No way.
no.
No, this is you. This is where Katie shines.
No, because I was going to show you, I was going to walk you through it. I was going to have you be my Vanna White. But okay, I tell you what I will have you do, and people in the chat room too. I am going to show you a couple of files. So we have our, what I don't know how to do is like show it to you in a way you can actually see. But we've got, you saw all this file. We have some sales data.
Mm-hmm.
So our column names, I'm just going to put it in the comments. Maybe I'll put it like, number 1, number 2, what do we have there? We have, we'll just start with that, and if we need the sales data, we can show you what's, that's not what was supposed to be there. All right, so we have people, and you guys want to give me ideas for what to do to try to
do what?
play with this? So, well, like for example, how do we look at, I figure we could just spend some time like looking at random things like, okay, how do I see what those column names are?
Everybody from one company, or first names.
Everybody from one company.
First names that start between A and M, or
I like it.
Yeah.
Okay, let's try. We'll pick DF1. Oh, there isn't even. Oh, it had it all loaded. Now it's got to like install the whole thing. That's okay. It's going to take me a while to type because I actually use the documentation every time I need any of this. So DF1 first. So first we'll just start. This is how we grab the first name column. And we have, let's see, A through what?
A through M.
Okay. I'm just going to do it between. Okay. That's a good question. Let's do that. Series between A through M. Pandas. Between. This looks promising. Okay. And
that's greater than and less than. Left boundary, right boundary.
Yeah, I wonder if it works on strings. Let's see if it does. Yeah, it does.
Oh yeah, it does.
Okay. So, and then let's see. Series, yeah, Pandas first character string. So, I don't even think I have to do the as type. So let's do that. Just tack it. I said to like break it up into variables, but I'm not going to because I'm living dangerous. So now you can see that what we printed was just, a new series, which was just the first letters.
First letters of the first name.
Yep. And now I'm going to go back to this other thing and say between So this should return a bunch of trues and falses. Stop between A, M.
Sure.
That's inclusive. Guess we'll find out because I think we have an M. Yeah, we have Marilyn Monroe. Yeah, she was in row 2, I think. So there's our true-false series. And if we do, I want to do this. I want to show you length of this series, and then I want to show you the lengths of both of them. You can see that they are both 7. Also, if we look carefully at the left-hand side, we can see that the actual indices are like 0, 1, 2, 3, 4 for both of these. And they don't actually have to even be in the right order, but the idea is that we have the set, like the set of row numbers. Or row, it's better to think of them really as row IDs because they could be words. But by the default, they're numbers. So those are the same, which is how I know that it's going to actually work when I do this. Because you want a true-false series with the same indices as your data frame if you want to filter your data frame's rows by that. So now I'm going to run it. And you can see that unlike in Excel, like we can skip numbers with the row. It's better, that's why it's better to think of them as row IDs than row numbers. Let's see if I can, I really should see if I can get this whole thing. There we go. And I could even then, another thing I can do is say that I want to see just the email column of such people. And that is going to be a series. How do I know? Because if I put it in type, it says so. What I want to show you then is, can I then say I want last name and email about those people? I can't, it yells at me. But if I make that a list of 2 different strings, let's see. Okay.
Need
Code
another
completion seems to have eaten a square bracket. Where do we go? That might not work.
Too many brackets? Kill one of the brackets on the other side of that list?
You know what I'm going to do? Filtered equals, sometimes this helps.
P is print.
Yeah, I defined a function that then does it with the line break and the divider, so that if I wanted to do more than one, you guys could follow it all.
Gotcha. Oh, there it is right there.
So I have just, you can see 0, 2, 3, 5, 6. We are skipping things. And what data type is that? Well, let's find out. It's a data frame, not a series. It's 2-dimensional, not 1-dimensional. It's a full-on table in its own right. So what if, for some reason, like just you're thinking about, again, I said data type influences what you can and can't do. You can do certain things with a series that you can't do with a data frame, and vice versa. So if for some reason you still want it, you wanted a 1-column table, you do not want a list-like thing of a column. You want a table that just happens to only have 1 column in it. What you do is you just make a 1-item list. Instead of saying print filtered string email, you say print filtered list of strings, just email. And so that is still a data frame as far as its type. I'm going to take off the type and show you what it actually looks like. Actually, what I'm going to do is I'm going to show you both, because there are subtle differences visually that once you know them can also help you, and you don't have to type check everything. A series, which is what that second one is, that's our 1-dimensional thing. It's going to give you its name if it has one, and it's going to tell you what data type is in it, which usually with text strings it says object. It might have said Boolean if we had a bunch of trues and falses right at the bottom of the thing. A data frame is not going to do that, and it's going to put the column name at the top.
Gotcha.
So once you've done this for a while, you may not actually have to do print type to know what you're dealing with. You might just recognize it on site. So
nice.
There's that. We're at 8:30.
and we're rubbing up to the top of the hour. Cool.
Yeah.
Katie, again, this was absolutely wonderful. Thank you so much.
Very welcome.
Cool. Let me make sure that, let me scrape the tweetospheres. People are saying thank you, great job, huzzah, all of the appropriate accolades. Good for them. Cool. Yeah, this was fantastic. Thanks very much, and we will definitely be chatting with you again in the future.
You're very welcome.
Cool.
Nice meeting everybody.
Everybody, thanks for joining us once again. We will be back next week with another Python developer to continue helping us upgrade our skills. Thanks again, and we'll talk to you soon.